not, you really kind of have to know exactly what you're doing to be able to figure this one out. Unless I did it the hard way. What's the first derivative of that function?
Um, 2x minus 1.
Where is that equal to 3, which is what that says?
Uh, 2.
So f prime of 2 equals 3, equals that, and then 3. Okay? So we know the point, at least the x coordinate of the point that they're talking about. In other words, we know what the slope is. If we could figure out what point is on the original function, then we have a slope and a point. And we can use the point slope formula and then solve it to put it in this format. So when x is 2, what is f of 2 in the original function?
2.
Yeah. So the point 2 comma 2 is on our function, right? Just looking at it, if x is 2, y is 2. Okay? And we know that the slope is 3 at that point, the slope of the tangent line. So let's figure out what the equation of the tangent line is using point slope format. What's the general format for point slope? This is the one you always have to use in calculus. You'll notice that you don't really use slope-intercept as much. And the reason you don't is because calculus is all about figuring out the slope from first derivative, and then they give you a point. So you very frequently have the slope and one point. And so that's why point slope is such a good format. Y minus y sub 1 equals what?
M in parentheses x minus x1.
Okay. We know most everything here. We know the slope and we know the point. So it's y minus, there's y1, there's x1. So it's y minus 2 equals 3 times x minus 2. That's the equation of our line. But notice that it's not in slope-intercept format. So we have to keep working on this. Distribute it. You get 3x minus 6. Move the 2 over, and you end up with y equals 3x minus 4. So that's the answer. But you can see that there was a lot to coming up with it. That's why I asked if you really knew how to do it, or did you just kind of guess? You said you tried points. Not quite sure what that means.
We didn't know. We just plugged in all the equations and see which one worked. Which one was a tangent to x squared minus x.
Okay. Still unclear as to how you did it, but let's go on. Especially since you got that one right.
Not the right way.
Well, maybe. I don't know. I'm still not quite sure how you did it, but let's not spend a lot of time on it. I think the way I did it is a good way to do it. It may not be the quickest. For one thing, you may not always have multiple choice. In other words, they could have asked that question without multiple choice, and then you would have had to do it my way. And you wouldn't have necessarily had to put your answer in slope-intercept format. You'd have left it in point slope, but that's fine. In calculus, point slope is the standard format. Well, I shouldn't have said standard. It's the normal format. And so you don't You get it in point slope format, you don't mess with it after that. That's the format you give the answer in. Don't really like the fact that they gave you your multiple choices in slope intercept. That's not really the calculus way. What happened on zero means you didn't get any points on this?
Those aren't zeros. Those are just circling because I forgot the units, which is just liters.
Okay.
Is it liters per atmosphere? Or is it
not. It's liters per, it's atmosphere per liters. In other words, if the X is the top and the Y is volume, then it's liters per atmosphere. Here's the way you can always figure out what the units are. Excuse me, hold on. Usually the top row is the X coordinate, right? That's the Y coordinate. That's the X. That's the Y. The Y is in liters. The X is in atmospheres, or atmospheric units. And so when you're figuring out rates of change, say I have this table and this is inversely proportional, so it goes something like this, okay? Well, if I want the slope of the tangent line right there, it's rise over run. And the rise is in liters, the run is in atmospheres. So you do end up with units, merely because you're dealing with a fraction. Yeah, okay. It looks like you've done this. All right. I usually do these the other way. In other words, no, I do them exactly as you did them. I just didn't look at it correctly at first. Okay, and this is 7.5 minus 11. Yeah, it's B minus A. You need a minus sign right there. All over 3 minus 2. Okay, so you knew how to do these. Find an equation for V of P using a power regression on your calculator. And you know how to do that?
No.
You have an Inspire, right?
Yeah.
Okay, do you know how to put in a list into a spreadsheet?
Oh, yeah.
Okay, your first column is going to be X, or volume, pressure. Your next column is going to be volume. Unfortunately, I haven't gotten a hold of a virtual calculator yet. Let me get my calculator. You got yours? If you don't, pull it out. Let me get it, and I'll show you how to do this. Tell me when you have it on and you're looking at the main menu.
All right.
Go down to that fourth thing where it said add lists and spreadsheet. Click enter. You should have a blank spreadsheet. Okay. Go up to where it says A and type PRESS from the keyboard. PRESS. go right, tab to the right, and type VOL. Luckily, we don't have a lot of data to put in. Now, go down to row 1.
Oh, okay. Wait, could I put it, sorry.
Okay, you can escape from this and start from scratch if you need to. But the name of the column is at that top row, not row number 1, the very top row, where mine says A. In other words, you want your X in column 1, you want your Y in column 2. And they have titles, both of them. Now, on row 1, under pressure, type 1, go down, type 2, go down, type 3, go down, type 4, go down, type 5, go down, type 6. Go back up to row 1 under volume. With me?
Mm-hmm.
Type, you're going to need to type all these because the next step requires you to have this list in there. So row 1 under volume is 22.4. Go down, 11.2. I'm doing this in mine at the same time I'm telling you about it. I wish I had a virtual one that I could bring up and we could do it together on that. I will by the next time or within a week. I'm just looking for one online, a good one.
Okay.
All right, you got both your lists in?
Almost. All right.
Now hit menu.
What?
Hit menu.
Okay.
And choose statistics. And then choose stat calculations.
Okay.
Get a long list of various regression models. Choose power regression, number 9. The X, it pops open a power regression window, and click on that gray arrow to the right.
Mm-hmm.
Required field is empty. Hold on a second. Let's see. Menu, statistics, stats, power. I gotta click inside those parentheses. I think I do. Question is, okay, how do you get in the parentheses? You do that. Notice that under the Y list, can you get the Y list when you, oh, I know how to do the X list. Let's see, I gotta go. Oh man, hold on. I haven't actually done this, I just knew how to do it, but a little trick. Okay, under the X list, I think what you have to do is back all of that up, hit enter. Now try going over to that gray arrow on the right, select it, there we go. When you select it using your mouse pad cursor, it pops open a bunch of things. Well, you want to choose press. That was our X column, right? The pressure. So select that. go down to the Y list. I think you can tap down to it. Hit your mouse cursor, and for Y, choose volume.
Okay.
Okay. Now you don't have to fill in anything else. Go down to OK. Hit enter. And you'll notice it immediately takes you back to the spreadsheet. And in columns C and D, it gives you the power equation. And notice that mine came out to be 22.4439, which is what you've got. Almost. You got 22.4431. I'll bet that's a 9 on your page that we're looking at.
Mm-hmm.
Because your calculator will give you A. In other words, what it's doing is giving you the power equation in AX to the B power. Okay? A being 22.4439, B being minus 1.0018. So that's how you ended up getting A times X. Here, let me write on here what this answer should look like, because I don't think you got it quite right. V of P, the volume, as a function of pressure, that's what that means, is equal to some A times X to the B. That's the power format. Okay? And your calculator told you that A was equal to 22.4439, and it told you that B was equal to negative 1.0018, right? Remember what the power thing is. It's A times X to the B.
Mm-hmm.
So this is going to be 22, I'm just going to round this off, 44 times X to the minus 1.0018. I don't want to round that off. Okay? In other words, this is your answer down here at the bottom. Volume as a function of pressure using the power regression is this equation. A power formula is merely where X is on the algebra line and it's raised to some power. In other words, it's not exponential format would be a b to the x. That's exponential. If you were to do an exponential regression and it gave you a and b, this is where they would belong. A times b to the x. But for a power regression, the x is not in the exponent. It is on the line. I don't know what you call that. It's on the algebra line, is what I always say.
Mm-hmm.
All right, so that's how you got it. And that little exercise should be very helpful for you, because what it means is you can now put in any table of numbers to lists and do linear regressions, exponential regressions, power regressions, quadratic regressions, any regression you want to do, it'll tell you, and it'll just read those two lists.
Okay.
All right. Scroll down here. Okay. Well, what do we have to do? We know what V of P is, right?
Mm-hmm.
even though you don't have it right here. Let me write what V of P is again. Here's V of P equals 22.4439 times X to this number, to the negative. B came out to be negative, right?
Yeah.
What's that?
Yeah.
Okay, so there's our V of P formula that the calculator gave us. And that's that number multiplied by X to that exponent. Okay, so if we're looking for the instantaneous rate of change, we're looking for V prime of P. Well, use the power rule and tell me what V prime is. And your calculator.
V prime.
Just use the power rule.
Um.
In other words, V prime is the first derivative. So you're using the power rule to figure out the first derivative of V of P.
Okay, give me a moment. Gotta get out of these.
Okay, yeah. You can always hit the scratch pad key.
Yeah, I know. It wasn't letting me open it, but now I got it. So, so it would be 22.4439
No.
times
The power rule. When you use the power rule, you always start with the exponent. That times that. What is that number? That's going to be the first number we're going to write.
negative 22.4843.
Okay, 4843 times X, and what's the new power?
Negative 2.0018.
Okay, so there's our derivative. And question C says use your model to find the instantaneous rate of change of volume with respect to P. Okay, we did that. That's that. Now compare the instantaneous rate when P is equal to 5 with the average rate from 4 to 5.
So would you just
What is, first of all, what's V prime of 5? Let's figure out what the instantaneous rate is. So plug in 5 for X and solve. Come up with a number. I'm not going to check you on these, so
I got negative 0.89677.
okay. Now it says compare that with the average rate from 4 to 5. Well, if we go back, from 4 to 5, what were the two? Oh, I can just look in my calculator. Hold on a second. From 4 to 5, we went from 5.6 to 4.5, right?
Mm-hmm.
So we went 4.5 minus 5.6 divided by 5 minus 4. Is that correct? At 5, it was 4.5. At 4, it was 5.6. Okay. That gives us negative 1.1. So, which is larger?
Sorry it took so long, the average.
What's that?
The average?
You see how I got the average?
Yeah.
I took v of 5 minus v of 4, and I divided it by 5 minus 4. In other words, rise over run. And I get minus 1.1 as an answer. Okay, so that's minus 1.1 as the average rate of change. This is minus 0.896, which is the instantaneous rate of change at 5. Now, it's interesting that they say which is larger. Which number is larger?
The average. Wait,
not on
no.
a number line. On a number line, that's why I say it's which is larger is a bit of a loaded question.
Sorry, it's the instantaneous.
Right. That's a larger number than minus 1.1.
Mm-hmm.
Okay. Which one has a steeper slope?
The 1.1.
Yeah, and it's negative regardless. In other words, if I were to graph this thing, as I go from 1 to 6, my values drop. Something like that. So I have a negative slope always. And if they're saying, what's the steepest slope? Well, it's the negative 1.1. What's the which is larger? They're talking about pure numbers. Well, in terms of pure numbers, v prime of 5 is larger than the average between 4 and 5. I don't really like that question because it's a bit confusing.
Yeah.
If you're looking for where is the rate of change the steepest, it's actually between 4 and 5. It's negative, but it's steeper. Why is this the case? I hate this question even worse. Why is this the case?
I don't know how to explain that.
Well, I'm not sure that anybody knows how to explain that. I guess it's the case because I don't know how to explain it. It's the case because the change between 4 and 5 is a different number than the instantaneous change at 5. They're always going to be different. It's very rare that your average rate of change will be equal to your instantaneous rate of change at a point. So why is this the case? Why is one larger than the other? It's based on the table and all of the calculations we did. I don't know what they want for that. So let's go on. I really don't know what they want. To me, those questions don't make a whole lot of sense. You got full credit on that? Plus 1.5 or each of these?
No, it's just for that top question.
Oh, okay. I got you. All right. Using limits, find the derivative of g, then use the derivative to find the equation of the tangent line. Well, the derivative is going to give us a slope, right?
Yeah.
And there's the point. So we're going to have a number for a slope. There's the point. And we're going to use point slope format. So you've set it up correctly here. The function is root x, and it's f of x plus h minus f of x all over h as h goes to 0. Why do we solve that? And let me get this up high enough where I can take a picture of it. That's a tough one to solve. Remember the technique you use for solving these when you have radical signs? You have
I
to
don't.
multiply the
Oh,
top and
it's a
the
one.
bottom. You can multiply that thing by 1 without changing it. Here's what my 1 is going to be. The conjugate. Make sure you see exactly what I'm doing here. I'm multiplying this fraction by the conjugate of the numerator. And I'm also multiplying the bottom by that conjugate. In other words, this is right here, that's the number 1. I can multiply any fraction by the number 1 without changing its value. Now, what do we get? When you multiply by the conjugate, you're basically looking at the difference of perfect squares factored. So I don't have to FOIL these. I can just say that it's this term squared. Well, what is that? That's x plus h minus this term squared. That's x. Now, that's my numerator. What's my denominator? H times. You with me?
Yep.
What's the numerator become?
H x plus h plus, square root x plus h. Wait, no.
The numerator. The numerator is that. Simplify it.
Oh, just h.
Okay. So now, and that h, you'll notice, cancels with that h. So what we're left with is 1 in the numerator. In other words, the x is canceled, and the h cancels with that h. In the denominator, we still have this, x plus h times, plus square root of x. Well, what is the limit of this as h goes to 0? In other words, now we're no longer looking at 0 over 0. If I look back up here, the top left circle, and I do a direct substitution, I have 0 over 0. So the way you handle 0 over 0 is, when you have radical signs, is to multiply by the conjugate, simplify, cancel out your h's if you can, and now what's the limit of that as h goes to 0? It's certainly not 0 over 0 anymore.
2x. 1 over the square root of 2x.
1 over 2 square roots of x.
Yeah.
Right? In other words, this goes away, and we have square root of x plus square root of x. That's 2 square roots of x. So that's the derivative function. Now let's just make sure we use the power rule, gives us the same thing. Use the power rule on that.
1/2 of x, 1/2 x to the negative 1/2 power.
That is the same thing as that. Right? X to the negative 1/2 is 1 over square root of x. Got the 2 in front of it from the 1/2. You with me?
Yep.
Okay, we're not done with the problem. Because all we've done is figured out our derivative. Now, let me erase most of this so that I can write. We've got our derivative function. What's the slope at the x coordinate of our point?
This would be,
let me put it in a little nicer format. 1 over 2 square root of x.
So it would be 1 over 2 square root of 3.
Yeah, so g prime of 3 is equal to 1 over 2 root 3. And before we waste time rationalizing that, let's finish the problem. We may or may not have to rationalize it. If we have to rationalize it, we'll do it at the end of the problem. It's always the way you want to do it. Sometimes if you rationalize in the middle of a problem, you end up having to re-rationalize it, especially with trig. A lot of trigonometry teachers will tell their students, do not rationalize, because the secant is the inverse of the cosine. So if you rationalize the cosine, now when you get the secant, I got an irrational denominator again. So let's wait till the end. But that is the derivative when x equals 3. So that's the slope. That's what that is. That's m. So what's the general format for point slope?
It's y1 minus y.
Nope. It's y minus y1.
Y minus y1. And in parentheses x minus x1.
Okay. Now fill in everything we know.
So we have we have the slope.
We'll start from left to right. What's y sub 1?
Root 3.
Slope is 1 over 2 root x. Excuse me. Slope is 1 over 2 root 3. Times what?
X minus 3.
There's your equation. And that's the final form. Unless you have an unusual teacher, they will not say, put that in slope-intercept format. They may say, okay, rationalize it, because you have an irrational denominator. So how do I rationalize that?
Just multiply by root 3.
Top and bottom by root 3.
Yeah.
Well, it means I got to multiply that by root 3 over root 3. What do you get? You get root 3 in the numerator. What do you get in the denominator?
6.
Times x minus 3. That's the answer they want. Notice it is not in slope-intercept form. It's in point-slope form. That's our slope. And there's our y point, and there's our x point. Now, I'm not sure why they made you do it the hard way. I guess they still go backwards every now and then, huh? You saw how hard the hard way was. We just did it. Compared to the power rule, which was one step. But the key is to find your slope and then use the point slope. Okay? That's the bottom of that page. I think I need to go back, open up another page. See what it says here. Do you want to just cover all of these or only certain ones?
All of them.
Okay. If f is a differentiable function, not all functions are, okay, then f prime of 1 is given by which of the following? It's one only.
Yeah. Why?
Notice why it's not 3. That is the definition of the first derivative, but it's only as h goes to 0. It's not as x goes to 1. So if it had said h going to 0, Well, then that would be the derivative function of f. It wouldn't be f prime evaluated at 1, though. Okay? This, in other words, there's another limit quotient definition where the derivative at a point, let's say f prime at c, equals f of x minus f of c all over x minus c as x approaches c. That is the second limit quotient definition. We haven't worked with this very often, you and I. We've always worked with the main definition because it's more robust. In other words, this only gives you the slope at a point 1. It doesn't give you the slope at point 2, doesn't give it to you at any other number but 1. But it does give it to you at 1. So, what is my answer going to be? F prime of 1 has to equal f of x, which is actually f of 1 minus hold on a second. I use this formula so seldom that I'm going to look it up just to make sure I have it right.
Okay.
I hate to make a mistake like that. All right. F prime of c is the limit of f of x minus f of c all over x minus c as x goes to c. All right, so f prime of 1 would be f of 1, which we don't know what that is, minus it's f of x, excuse me, minus f of 1 all over x minus 1 as x approaches 1. In other words, by this definition, it's a different definition than the previous problem we did. We used the more robust definition for the previous problem. But this one, we got to use this definition because of their multiple choice answers here. Well, do we have any that look like that? Oh, we sure do. That one right there, and that's the only one that looks like that. It's definitely not, in other words, whoops. That one right there fits that definition perfectly, right? It's f of x minus f of 1 all over x minus 1 as x approaches 1. The first one, that doesn't fit anybody's definition. 1 plus h. You have answers on these? You circled 1 and 3 only. I didn't see any points awarded here. That means that's not the right answer? You chose D.
Yeah, but it should be A.
Well, I think it should be B. B is definitely correct. I meant number 2 is definitely correct. So it's either B, C, or E. They all have number 2 in there. But I know number 1, not correct. At least I don't think. Never actually tried to figure it out that way. Maybe number 1 is correct. In other words, this one right here. That might actually be a way to do it. That is f of x plus h minus f of x all over h, the limit of that, and then whatever you get, you substitute 1 for x, so it might be 1 also. It could be 1 and 2, so it might be C. 3 could be 3 also, because that is the other definition, but it's as h goes to 0, which you have to do first. It's not as x goes to 1. Although as x goes to 1, 1 would be the same as 3. It's a little tricky, and I understand this stuff good. 2 is definitely correct. I'm trying to figure out if 1 would be correct or not. 1 could be correct, and 3 might even be correct. Yeah, I suppose if you did that calculation, well, first of all, you got to let h go to 0. So I don't think 3 is correct. 1 could be correct. I know 2 is correct. All right, let's go on. Has she scored this yet? Has this just not been scored?
Yeah, that's right. No, we had 2 tests, 2 quizzes, because it's a partner one. It's created the other one.
Oh, so this one hasn't been scored yet?
No, well, yeah, it has.
Is this the individual one? The other one was the partner one?
No, both of them are partner.
Both of them are partner? That's why the problems are extra hard. Okay.
Yep.
How many points in the interval between A and J, between here and here? Where's J? Where the heck is J? Oh, I guess that's J right there. It looked like an F. Doesn't that look like an F?
Mm-hmm.
Well, where's J? In other words, that's C, D, E, F. They don't have a J on there. So I can only guess that they meant this point. It's the only way this problem makes sense, is if they mean that point there. How many points is the derivative not defined at? What's the first point?
The first point, B.
Okay, that's 1.
And then
The next one.
the y-axis.
0.
Yeah, 0.
Okay, what's the next one?
C.
And the next one?
E.
So 4 points. It is defined there and there. In other words, the slope of the tangent line there is the slope of that straight line. The slope of the tangent line here would be something like that. So it is differentiable at the endpoints. It's just not differentiable at corners, cusps, discontinuities, jump discontinuities. It's a good one. This will take us the rest of the 10 minutes. I'm guessing, just because there's so many derivatives they want here. What is the value of f of x when f triple x equals 0? Well, what do we have to do? You've done it. You've got the first derivative, which looks correct. You've got the second derivative, which looks correct. And you've got the third derivative, which is 60x to the third power minus 60. That's the third derivative. See why? When you went from the second derivative to the third derivative, you had a power of 4 there. You only lose 1 power. Jake, you still there?
Yeah.
Did you see why the third derivative is 60x cubed minus 60?
Yeah.
Okay. And they're saying the third derivative equals 0. Well, solve that equation.
I just got 1 out of that.
Well, we've got x cubed equals 1. So the cube root of 1 is indeed 1. Now what's the value of f of x when x is equal? In other words, what's the value of f of 1?
It would be 5/2.
Well, let's just go through it. 1/2 minus 10 plus 12. So that's 2 1/2, 5/2. There's your answer right there.
Cool.
Okay. Well, that didn't take as long as I thought because you'd already done half of it.
Mm-hmm.
Using limits. Are they kidding me? How much? How often?
I had no idea. I literally had no idea how to do this one.
Well, it's not that hard. It's just, why are they going backwards? They just spent the last 2 weeks teaching you the power rule, the product rule, and the quotient rule, and the chain rule. Why are they going back to forcing you to do this the hard way? All right.
No clue.
This is correct right there. Oops, hold on. Move it up a little bit and take a picture of it so I can write. All right. How do you do these? When you say no clue, what's the first thing you have to figure out?
Wait, would I just put in 3x plus h squared?
Always begin these problems like this. What's that equal to and what's that equal to? What's f of x equal to?
3x squared plus minus 4x.
What's f of x plus h equal to?
3x plus h squared minus 4x plus h.
And you just have to do the math now, because here's what we have. We have, well, let me just erase this and I won't have to erase that and rewrite it. So that's f of x plus h. We're subtracting f of x, parentheses, because we're subtracting all of f of x, not just the 3x squared. We're subtracting that. It's all over h. We're going to take the limit of this thing as h goes to 0. Now, what's going to happen when we do the algebra here is that every term that has an h in it, or that doesn't have an h in it, is going to disappear. Let me do it real quick because we only have 5 minutes. I'm going to do this math. Okay, I'm going to do it up here in the upper right. Here's what we have. 3, this is x squared plus 2xh plus h squared. You with me?
Mm-hmm.
Minus 4x minus 4h minus 3x squared plus 4x. You see why that's a plus?
Yeah.
Okay. Now distribute the 3, and so I can remove these parentheses, make that a 6, put that 3 there, and just remove the parentheses. Okay, now notice I got a plus 3x squared and a minus 3x squared. I got a plus 4x and a minus 4x. Well, what does that leave me? That leaves me 6xh plus 3h squared minus 4h in the numerator. In the denominator, I got h. See how these come together. In other words, because every term without an h disappeared, it means every term in the numerator has an h in it, which means I can now factor out an h and cancel it with the bottom. So here's what I'm looking at for my final function. 6x plus 3h minus 4h. What is the limit of that as h goes to 0? I don't even need to combine them.
0.
No. The h goes to 0, but 6x doesn't.
Oh, yeah.
Somehow I missed a minus 4. Where did I lose the minus 4? I was doing it so quickly I must have missed a minus 4. There's still a minus 4 here. I know because if I apply the power rule to that, it's 6x minus 4, right?
Yeah.
So doing it this method has to give me the same answer. Now, when I did it, I must have just made a mistake by going too fast, but the answer comes out to 6x minus 4. That's using limits, find the derivative of the following. That's exactly what we did. Okay? So that's a good place to stop.
All right. Well, thanks.
Yeah. Tell your mom I'm going to answer what we talked about earlier today. I'm going to send her an email, and she'll probably get it in the morning.
Okay.
Okay? She'll know what I'm talking about.
Okay.
Okay. Jacob, I will talk to you next time.
All right. I'll see you.